Okay, we're going to continue with finding missing angles of a triangle. We learned in the previous video that all we had to do was add up the two angles that we did know and subtract from 180 degrees, and that would give us the measure of the missing angle, that third angle. We also learned that knowing about their sides, whether we're talking about an isosceles triangle where two sides are equal, or if we're talking about an equilateral triangle where three sides are congruent or equal, or whether it's a scalene where all three sides are different, that would help us determine missing angle measures as well. If we were given an isosceles triangle with one of the angles, we knew that there was another angle that was congruent to it, and from there we could add them together and subtract from 180 degrees. We also knew that if we had a right angle in a triangle, that the right angle measured 90 degrees. There's another way you can also solve for a variable or a missing angle measure in a triangle, and that is by using equations. Sometimes you're going to be given triangles like the one you see here where the angles involve a variable. We can still use the rule that we know that all of the angles add up to 180 degrees to solve for the variable and then determine the actual angle measure. So go ahead in your packet, turn to page 4. Okay, I've done a couple here for you just to show you, give you an example. Okay, number 1, again, we want to solve for s. They're asking us here to solve for the variable. So we know that all three angles together will add up to 180 degrees. So let's add them. My lower left-hand angle is 4s plus 3. 63 degrees is another angle, and my third angle measure is 54 degrees. If I add up all three of those angles, it should equal 180. That's my equation. Now sometimes when solving equations before you can actually solve, you have to combine like terms, which is the case here. We have three different constants that we need to add them together. 3 plus 63 plus 54. When we add them together, we get 120. So our actual equation is 4s plus 120 equals 180 degrees. And now we're ready to solve our equation. This is a two-step equation. We've done two steps before. We know we need to get rid of the constant. So to undo this 120 to make a zero pair, we need to subtract 120. And we have to be fair and share, do the same thing on the right side of the equation. Once we subtract 120 from both sides, that leaves us 4s equals 60. And now to isolate the s, we just divide by 4. And we get s equals 15. So that is the answer to our question. We're supposed to solve for the given variable. So s is going to equal 15. Now, if we wanted to determine what the actual angle measure is, we could just substitute the 15 into that expression. 4s plus 3, substitute 15. 4 times 15 is going to be 60, add 3, and that angle measure is going to be 63. Sorry, I can't write very well with the mouse. That angle measure is going to be 63 degrees. So that tells you if this angle is 63 degrees and this one is already 63 degrees, then they are congruent, which means I have two sides that are congruent, so this would be an isosceles triangle. Okay, let's come down to number 6. Take a look at number 6. Again, we want to add up all three sides, so we're going to have 33 plus 114 plus 5f plus 3 equals 180. And we want to solve and find the value for the variable f. So again, combine your like terms, add all of your constants together, and it's going to give us 150 plus 5f equals 180. Solve your two-step equation by first making a zero pair out of the constant. Subtract 150 from both sides, leaves us 5f equals 30. And now isolate the f by dividing both sides by 5, and you get f equals 6. So that is the value of the variable. If we wanted to find out what the actual angle measure was, we could substitute it back in. 5 times f, which is 6, plus 3. Well, 5 times 6 is 30, plus 3 is 33. So again, we have another isosceles triangle. This one would be an obtuse isosceles because the third angle measure is greater than 90 degrees. Back in number 1, since all of our angles were less than 90 degrees, then that was an acute isosceles. And this is how you're going to use equations to solve for either variables, angle variables, or angle measures.